All right. Good morning again, everybody. So I think we're recording now. Welcome. So last meeting natin for the week to math for math 151 weekend. Here we come. Pero before that, we'll just try to finish as much as we can for the intended coverage of this week. Kasi naging medyo dun sa ating course outline, the objective or the target is to finish to finish sections 2.1 until 2.3 this week, right? Pero meron kasi akong mga carryover discussion from last week kaya hindi natin nasimulan kagad yung linggo with section 2.1. So medyo we're behind schedule but that's fine. We'll take our sweet time. Saka na lang tayo mag-adjust towards the end, ano. So what did we do last time? Well, we started solving differential equations, right? But we said we started with the simplest class of differential equations, namely yung mga separable differential equations. But before going further, are you seeing my slides or ano rin ba siya? Stuck dun sa Teams screen. I think it's stuck. Let me try resharing my screen. Okay, thank you, Victor. Yeah. Okay na kanina na share screen ko na kaya lang for the benefit of those who came in just right just on time, so kailangan kong ulitin yung sharing ng screen. Let's see. Okay, there we go. So we were talking about the first class of differential equations na sinsolve natin. That's separable differential equations. And we said these are equations that can be written in the following form. So you do some algebraic manipulation to the end goal of writing your differential equation in this manner. So we want it to be something like f of x dx equals g of y dy, right? And that's the essence of separating the variables. We want those which involves the variable x to be on one side, while those involving the variable y would be on the other side. And this is our dream. This is our goal. Kasi kapag ka nasulat mo na siya na separated yung dalawang variables, you can get rid of the differentials by integrating both sides of the equation. Ang tanging kalaban na lamang natin dito ay paano nga ba mag-integrate? Because the functions f and g here could be complicated functions. So you need to review basic integration formulas as well as the integration techniques na natutunan nyo from math 36 and 37. And then just don't forget, once you integrate, at least introduce one arbitrary constant, right? Pag in-integrate nyo to, halimbawa, karoon ka ng capital F of x, which is the antiderivative of f, right? Equals, integrate g, so you get capital G of y. Don't forget the arbitrary constant, okay? And since all the differentials are gone, wala nang trace ng mga derivatives ka makikita with this relation here, this could be our final answer. So that means this will represent the family of curves na magsosolve dun sa ODE. Of course, it will depend on a parameter C kasi wala tayong initial value na binigay. Right? And then my only request, whenever possible, write your solution in terms of explicit form. Meaning you try your best to isolate y on one side and give, say, a function of purely x. So probably this could be, say, h of x plus your arbitrary constant c. So this is what we call an explicit form for the solution, because the variable y, which is the dependent variable we're looking for, ay nakasulat explicitly in terms of the independent variable and the parameters. All right? Pero kung hindi talaga kaya, then you leave your answers like this. Okay? So to refresh our memories a bit, let's try another example of separation of variables. Okay? So tingnan natin, ano yung solution ng differential equation? The y squared square root of 1 minus x squared dy equals arc sine x dx. All right? You can clearly see that this is separable kasi ano lang problema. Okay na yung right side, no? Puro excess lang yung nakikita natin dyan. Ang problema ay nandun sa left wherein you have this expression involving x, pero nakasama siya dun sa mga may y. But that's not a big problem. We can simply divide both sides by 1 minus x squared, and then we'll have a separated dE, right? The variables will be separated from each other. So let's write our solution for this. So solution, remember, I'll start with, tama ba? Y squared yun, no? Sorry, meron akong short-term memory. So, short memory span. So, yeah. Square root of 1 minus x squared dy equals arc sine of x dx. All right. Then I'll carry on the plan. I'll divide both sides by the square root of 1 minus x squared to give us y squared dy equals arc sine of x all over square root of 1 minus x squared dx. Now the variables are separated from each other. All we need to do is to integrate, right? So we integrate both sides of the equation. This will be an implication of the previous line. So I put the implications symbol there, right? Madali lang i-integrate yung nasa kanan, nasa kaliwa. So this will just be what? Sorry. This will just be y cubed all over 3. Mamaya ko na ilalagay yung arbitrary constant because I'll still have an integral all over the right-hand side. So, sulat ko muna yan dito. Dx. And then here, I need a simple u substitution to evaluate this integral. This looks scary kasi napaka-komplikado ng function, but I hope you remember that 1 over square root of 1 minus x squared is the derivative of arc sine. So a simple substitution of u equal to arc sine of x will simplify this so much, right? So that's what I'll do here. So I will let u be equal to arc sine of x. That means du is 1 over square root of 1 minus x squared dx. So the 1 over square root of 1 minus x squared dx I see over here will be replaced by du. And then the arc sine will be replaced by u. So essentially, we'll have this. Y cubed over 3 equals the square root of what? U du. Tama? All right. And then that's easy to integrate. This will just be u squared over 2 plus an arbitrary constant c. And then we can what? I should revert back to the variable x. So this is arc sine squared of x all over 2 plus the arbitrary constant c, right? And then this is y cubed over 3. Well, this is a representation for the solution. But again, whenever possible, try to write your answer in explicit form para mas madali siyang i-analyze if we need further analysis. So here I want to isolate y, and to do so, I need to multiply both sides by 3, then take the cube root. Well, whenever you're taking the third root or an odd root of an expression, that's fine. Pero medyo mas careful kayo kung naging y squared to. Kasi pag y squared yan, nag-take ka ng square root, yung principal square root laging positive lamang. So be careful kapag may mga even powers because when you take an even root, baka mapaliit nyo yung domain ng given relation. Kasi pag sinulat mo na siya na y equals square root of something, you're saying that y is always positive. But there could be cases dun sa implicit form na si y ay posibleng maging negative, right? So be extra careful kapag even yan, better not to take square roots or take fourth roots or sixth roots. Pero kapag odd lang naman yan, yung pagkuha naman ng odd roots ay hindi nakakabago dun sa domain o dun sa range, so safe na kumuha ng odd root. So I'll do that. So here, I'll multiply first both sides by 3 to get rid of the 1/3 from the left. So I'll have y cubed equals 3 halves arc sine of x, arc sine squared of x plus 3 times c, right? But I'll write 3 times c as arbitrary constant k na lamang. Our convention, capital letters will represent arbitrary parameters or arbitrary constants para hindi na natin laging isusulat na k is a real number and so on. So by default, yun yung ating convention sa klase. then I take the cube root of both sides. So this will become y equals cube root of 3/2 arc sine squared of x plus the arbitrary constant k, and this is our explicit solution. All right, so that's end of solution. Okay, all good. So if you want to if you want to take a snapshot of your screens, go ahead. Pero nandun naman to dun sa slides, no? Yung solution din naman ay nandun sa slides na ina-upload ko sa Canvas. Ayoko lang nung nagkiklik lang nung ng PowerPoint. I want to do it by hand. So para sama-sama tayo nag-iisip. Hindi yung taga-click nyo lang ako ng PowerPoint. Ano? Alright? So I think there's another example here. Oh, wala na pala. Tapos na pala yung section. Any questions about separable differential equations? Well, it seems short because we only considered, I think, 2 or 3 examples of separable differential equations. But don't worry, the next section will again involve separable differential equations. Okay? Ano lang ang kalaban natin sa separable differential equations? Ang kalaban lang natin talaga ay yung pag-integrate. At hindi lang hindi lang dito natin sila makakalaban, yung pa rin yung kalaban natin halos sa buong course, how to differentiate, how to integrate. So I hope you reviewed your basic calculus, all right, or your intermediate calculus. All good. So let's put this section to rest. But if you wish to do some practice, so try to answer the exercises at the end of the lecture slides. So meron diyang 5 problems. So try to work this out and then let me know what happens. Okay? Kung may problema, tanong nyo sa akin sa next week, all right? When before we start Wednesday's lecture. Okay? But I hope you try these. Kasi iwanan ko na siya for now. Let's go to the next section, which is about, hold on, ODEs with homogeneous components. Okay. So in this particular section, magko-consider kasi sabi ko sa inyo halos sa buong course, ang gusto natin gawin ay mag-solve ng mga ODEs. Kaya lang yung pag-solve ng mga ODEs nakadepende kung ano yung itsura ng ODE. Na-consider na natin yung pinakamadaling cases, yung mga separable differential equations, simple integration. Pero hindi lahat ng mga ODEs ay separable, right? So ibig sabihin, titingnan natin yung ODE, hindi siya separable. Ang susunod natin gagawin ay itry natin baka siya ay may homogeneous components. Kasi pag may homogeneous components siya, kaya natin siyang isulat in such a way that the variables are separated after a change of variable is implemented. Okay? Pero again, this method, yung section 2.2, nag-work lamang siya kapag yung ODE natin ay may homogeneous components. What do we mean by homogeneous component? Siya yung nandito sa definition na to. So a function f of 2 variables, x and y, but again, our assumption is that the variable y is dependent on the variable x. This function f is homogeneous of degree n if, okay, dapat mangyari to para masabi natin na yung isang function ay homogeneous na ang degree ay n. Kapag sa lahat ng lambda, x and y, this equation is true. Dapat yung f of lambda x comma f of lambda y. So that means when you replace the variables x and y in the definition of f by lambda x and lambda y respectively, you should get lambda to the n times the original function f. Right? So si n dito ay isang specific value, and that's the degree of the homogeneity of your function. So homogeneous siya of a specific degree kapag this equation is true. But this guy or this equation should be true for any value of lambda, x, and y. Dapat totoo siya sa lahat ng lambda, x, at y for a specific degree n. Right? So let's see an example. So for instance, our function is x squared plus y squared. And we want to show that this is a function of 2 variables that is homogeneous. of what degree, we'll also see through the solution. Okay. So what I'll do here is I'll first try to see this. Okay. Palitan ko lahat ng x's at saka lahat ng y's by lambda x and lambda y. And I'll try to see if I can factor out the original expression for f. Tapos ang natitirang multiplier dapat ay lambda to some power. Okay? Yung power n, it depends on the situation, but we are free to choose the value of n. Pero dapat si lambda, si x, at saka si y ay arbitrary. There should be arbitrary real numbers. Okay? So let's do the first step. So here, to check if it's homogeneous, we'll compute f of lambda x, lambda y. So kay f, lahat ng x at y, papalitan ko lang ng lambda x at lambda y respectively. So we'll have, instead of x squared like this, I'll have lambda x quantity squared plus lambda y quantity squared. Right? Pinalitan ko lang si y ng lambda y. And then I'll try to manipulate this and see if I can write it off this form. Dapat masulat ko siya na lambda n times the original f, which is x squared plus y squared. We should be able to find a small n, a little n, such that this expression here is of this form. Right? So kailangan kong pala itong i-simplify muna. So this would be lambda squared x squared plus lambda squared y squared. At pwede ako mag-factor ng lambda squared. This will be lambda squared times x squared plus y squared as I wanted. Because look at this factor. This factor is exactly the function f that we had earlier. So that means this is lambda to the second power times little f of xy. And so we can conclude, so f is homogeneous of order 2. Because this guy is equal to lambda squared, that's n equals 2, times the function f for any lambda, x, and y. All right? So madali lang, magpakita na homogeneous of a certain degree, right? So kunin mo lang ito, sulat mo, expand mo siya, and hopefully, makapag-factor ka ng power ni lambda times, or ma-factor mo siya na power ni lambda times the original function f. All right? Sounds simple? Dapat. Dapat simple pa lang to. Ito yung problema. Hindi ko nakikita mga reactions nyo kung nag-agree kayo na simple lang yung gagawin. And this is the first step because yung ituturo ko na technique ngayon, mag-work lamang kapag yung equation natin ay may lahat ng components niya ay homogeneous of the same degree. Right? Makikita niyo mamaya kung paano. But before going there, let's see a counterexample or a non-example. So let's try this, x squared plus 3y. Again, we want to check if this is homogeneous of a certain degree. So what I'll do is compute g of lambda x, lambda y, and see if you can write it as lambda to the power n times g of xy. Right? Lahat ng x's, papalitan ng lambda x. Lahat ng y's, papalitan ng lambda y. So I'll have lambda x quantity squared plus 3 times lambda y. Okay? And this guy will be lambda squared x squared plus plus lambda, unahin ko yung mga lambdas times 3y. Now, can we write this as some power of lambda times x squared plus 3y? Can this guy be seen to be of that form? What do you think? Kaya ba nating isulat ito sa ganitong paraan? Yeah, Rancis is right. Thank you, Rancis. Hindi. Kasi this will be lambda. So if it can be written that way, this could be this should be lambda to the n x squared plus lambda to the n 3y. Pero oops, sorry. Okay. Pero hindi kasi magkaiba yung power ni lambda doon sa dalawa. Yeah, thank you, Kian, Bernadette, Gab, and Dino. Yeah, hindi pwede. All right? Kasi nga magkaiba yung lambda. So at most, we can factor it as lambda to the power 1 times lambda x squared plus 3y, but the second factor is not g of xy, right? Or if you want to be, so okay na to sa akin, pwede nyo sabihin dito, therefore, g is not homogeneous of any degree. So hindi siya homogeneous. Kasi hindi natin siya kayang i-factor na lambda to the n times g of xy. All right? If you want to be more technical about it, and I think ito yung pinakita dun sa lecture notes, nagawa pa siya ng proof by contradiction. But again, for me, this is enough. All right? This is enough. Clear kasi na makita na hindi ko siya kayang isulat as lambda to the n times x squared plus 3y. That's fine with me. But kung nag-i-insist kayo na, sir, gusto ko pa ng mas malaking ebidensya, pwede kayo mag-proof by contradiction. Pero again, for me, that's unnecessary. Pero just to complete the discussion, so you can say na, okay, suppose that g of lambda x, lambda y is equal to lambda of g of xy. Lambda to the n times g of xy. Suppose, kunwari, remember that's proof by contradiction, classic. Suppose na siya ay homogeneous of order n or of degree n. So dapat totoo ito. Pero na-compute na natin itong g of lambda x, lambda y, alam na natin yan ay equal kay lambda squared x squared plus lambda 3y. That's this guy is lambda to the n times x squared plus lambda to the n times 3y. All right? So kung homogeneous siya, so dapat totoo itong equation na to for all. Dapat ito ay totoo for all lambda x, y in R. Totoo siya dapat sa lahat ng lambda. Sa lahat ng lambda, sa lahat ng x, sa lambda y. So kung totoo siya sa lahat ng posibleng values ni lambda x and y, so if y equals 0, the equation should be true, right? So if I replace y by 0, I'll have what? Lambda squared x squared plus 0 equals lambda to the n times x squared. Right? Yan yung mangyayari kapag si y ay equal kay 0. So pwede ko itong gawin. Ito yung tinatawag natin na universal exstantiation. Totoo kasi ito sa lahat ng y, right? So pwede ako magbigay ng specific y. To illustrate the absurdity of this assumption, I will replace y by 0. Kasi masasabi ko ron kapag si y ay 0, I'll get that n should be equal to 2. Right? Dapat dapat si n ay equal kay 2 para maging totoo itong equation na to. And that's fine. Wala pa ako na-violate so far. So if G happens to be homogeneous, it should be homogeneous of degree 2. Okay? Kung homogeneous nga siya. Pero yun nga yung pinuprove ko na hindi siya homogeneous. Okay? So saan ako kukuha ng contradiction? So far, wala pang contradiction. Everything is fine. Okay? So therefore, gamitin ko tong information na to na si n ay equal dapat kay 2 dito sa equation ng homogeneity. So that means, so we'll have this. We'll have lambda squared x squared plus lambda 3y equals lambda squared x squared plus lambda squared 3y. Kasi nga nalaman natin mula dito na kung siya ay homogeneous, siya dapat ay homogeneous of degree 2. So dapat itong mga n na nandito ma-replace by 2. Okay? Oh, but I have a lambda squared x squared here, another lambda squared x squared there. So I'll be left with the statement that lambda 3y ay equal kay lambda squared 3y. But I can divide both sides by 3y. So this means lambda equals lambda squared. But the equation lambda equals lambda squared is true only when what? This is true only when lambda equals 0 or lambda equals 1. Kasi kung siya ay homogeneous, siya dapat ay homogeneous of degree 2. At kung siya ay homogeneous of degree 2, nakita natin dito na si lambda dapat ay equal kay 0 o kaya equal kay 1. Okay? Everything's good so far? Everything should be good except that This is a contradiction. Why do you think is there a contradiction here? And that contradiction really proves that indeed hindi pwedeng maging homogeneous si G. Bakit hindi siya pwedeng maging homogeneous? Bakit sabi ko ay may contradiction dito? Okay, Justin, that's very good. Also, Dino, tama. Kasi necessarily, para maging totoo yung pagiging homogeneous niya of order 2, dapat daw si lambda ay equal kay 0 o kaya equal kay 1. Pero ang sabi ng definition, tama rin si Kiefer, dapat totoo ito sa lahat ng lambda na real number. Pero totoo lang siya sa dalawa. So, ibig sabihin, hindi siya homogeneous of any order. Right? So, that means G is not homogeneous. This is for those pure math aficionados. Pero sa akin, okay na talaga to. Kasi clear na hindi siya homogeneous. Right? So let's see some properties of homogeneity before digging into the actual solution for homogeneous differential equations. But, Crystal has a question. Crystal, no. Hindi natin pwedeng gamitin interchangeably yung degree at order. Though minsan napagpapalit ko sila, no? Ang tamang term ay dapat degree. Pag homogeneity, degree yung ginagamit natin. So, yeah, sorry kung medyo nagamit ko yung order, pero dapat degree yung ginagamit ko. Alright? So, slip of the tongue. Pero homogeneity, dapat degree yung description natin. Right? Okay, so some properties of homogeneity. Okay, theorem 2.2.1. So kapag meron akong dalawang functions, m and n, and they are both functions of x and y and are of homogeneous of the same degree, sinasabi ng theorem, yung quotient nila ay homogeneous daw of degree 0. Okay? So if you want to prove this, we'll start with the assumption that m and n are homogeneous of the same degree. Okay? Tapos gusto kong tingnan ano yung homogeneity or ano yung degree ng homogeneity ng m over n. Actually, the first question is, homogeneous nga ba yung m over n? Okay? But we can work it out. So let's write the proof. So maybe we can say from the assumption, so there will exist a natural number n such that homogeneous of degree n si m at saka si n. Anong ibig sabihin ng pagiging homogeneous nila? Apply natin yung definition. So such that m of lambda x, lambda y, ay equal kay lambda to the power n ng mxy, and n of lambda x, lambda y, ay equal kay lambda n of xy, for all lambda, x, and y in R. Okay? So sabi ng assumption, kunwari si m at saka si n ay parehas homogeneous of degree n. Gamitin ko yung definition ng homogeneity. Kung sila ay homogeneous of the same degree n, ibig sabihin, meron akong pang-exponent sa kanya, right? Na totoo itong homogeneity equations. Invento ko lang yan. Tawagin lang natin siyang homogeneity equation, para hindi ko babasahin yung buong line. So this is what we call the homogeneity equation, at least for our class. Tapos ano yung gusto natin ipakita? The goal is to check whether m over n is homogeneous. And further, we want to show that m over n is homogeneous of degree 0. Yun yung goal natin. So check natin, ano yung itsura ni m over n of lambda x, lambda y. Because again, ganito tayo nag-check ng homogeneity. Yung function na gusto nating i-check kung homogeneous, papalitan ko lahat ng x's by lambda x, papalitan ko lahat ng y by lambda y. Here we're checking if m over n is indeed homogeneous. So, kay m over n, lahat ng x's papalitan ko ng lambda x, lahat ng y's papalitan ko ng lambda y. By definition of the function m over n, this is simply the ratio of m over lambda x, comma lambda y, over n of lambda x, lambda y. Yan yung definition ng quotient ng dalawang functions. But from the homogeneity equations, this guy and this guy, all right, pwede kong isulat yung m lambda x lambda y as lambda to the power n ng m of xy over lambda n of nxy, right? Using the fact that m and n are both homogeneous, or using these equations. And then now, we can cancel the lambdas, right? So, ibig sabihin, kakancel yan. Matitira lamang, dito ko na lang sulat, m x over y, equal yan sa n x over y. Okay? But I can write this as lambda to the power 0 ng mxy over nxy. Pero by definition, this guy is simply m over n evaluated at x comma y. Okay. Review natin, ano yung meron tayo? Yung m over n evaluated at lambda x comma lambda y ay equal kay lambda 0 times m over n evaluated at x comma y. So at this point, we have shown that m over n is indeed homogeneous. At ang degree ng homogeneity niya, yung exponent ni lambda. So therefore, we can say, m over n is homogeneous of order 0. End of proof. Okay? Any questions? Nagme-make sense ba? I hope it does, okay? Kaya lang sabihin nyo, papakamot kayo ng ulo, sir, bakit may proving sa 151, ano? Ganun talaga. Pagka umabot na sa 100 level yung mga math courses na tinitake nyo, ano talaga yan? Meron ng halong mga proving. Kasi hindi lang tayo nagko-compute. Laging merong theory aspects doon sa ating discussion. Okay? So if this is fine, let's proceed to another theorem na medyo introduction doon sa solution method natin. Sorry. Para sa mga equations of equations with homogeneous components. So theorem 2.2.2 is telling us na kapag ka meron kang homogeneous function of degree 0, so si m pwede mong isulat as a function of y over x alone. Okay? So let's assume, so sa proof niya, alam na kagad natin na si m ay homogeneous of degree 0. So our assumption here is that m of lambda x comma lambda y ay equal kay m xy lang. Kasi nga homogeneous siya of degree 0, so there should have been a lambda raised to the power 0 here, but lambda to the 0 is just equal to 1. Okay? So ito yung ating assumption. Now, what I'll do here is I'll introduce another variable. So I will let y be equal to, say, vx. Okay. Of course, that will mean that whenever x is not equal to 0, so the new variable v is equal to y over x. Take note of this change of variable because we'll use it in our solution for equations with homogeneous components. Okay? So take note nyo lang yan. So then, yung m of xy, pwede ko siyang isulat na m of x comma vx. All right? Tapos, if you think about it, I can say that this is the same as m of what? X times 1 comma x times v. All right? Tapos sabi ng homogeneity ng m of degree 0, kapag ka meron kang multiplier dun sa arguments, pwede siyang mawala. Right? So yung lambda na multiplier dito, and this should be true for any lambda, right? So nawawala lang siya, natitira lang si x and y. But look at what I have over here. Meron akong multiplier dun sa mga arguments. Meron sila mga x na nasa unahan nila. Itong homogeneity equation sa lahat ng lambda. So this equation will be true if I will treat lambda to be equal to x. And then the variable x here is the specific value 1. Tapos ang variable y dito ay si v. So yun yung idea ng homogeneity, di ba? Yung common factor dun sa mga arguments na babaliwala sila kapag ka homogeneous of degree 0. Supposedly, magkakaroon ka dyan ng x to the 0, mawawala siya dun sa loob. Right? So essentially, by the homogeneity expression or equation, this is m of 1 comma v. But what is v? When x is not equal to 0, v is y over x. So, ibig sabihin, pag in-expand mo pala si m, kaya mo siyang isulat na ang variable lamang ay si y over x, which is as claimed in the theorem. Si m ay function lamang ng y over x. Yung first argument niya ay 1. That's a constant. So, it's not counted as a variable, right? So, ang variable lang talaga kapag ka homogeneous of degree 0 ay si y over x. So, that ends our proof. Okay? And this is the sort of the idea. This is the stepping stone in the solution scheme that we will develop. Kapag ka homogeneous yung isang or homogeneous yung components ng isang ODE, we can just introduce this change of variable. We can let y be equal to v over x or the other way around. So or pwede rin siyang x equals vy. Doesn't matter. Either of the two will work. Kaya lang siguro yung isa mas mahirap kesa dun sa isa. Depende dun sa technique of integration na kakailanganin natin. But the thing is, once you perform these substitutions, then the ODE with homogeneous components will be a separable one. Separable siya in the new variables v and x or y and v. All right? So tingnan natin. Siguro mas madali siyang tingnan via specific examples. Pero again, limitado tayo dito sa pag-work sa mga equations na may homogeneous components. Kasi kung wala siyang homogeneous components or hindi lahat ng components na ay homogeneous, hindi siya magiging separable after the change in variable. Okay? So hold on. Excuse me, guys. Okay. So for this example, let's first check kung homogeneous yung mga components ng ating ODE. You can think of it as our component M, and this is our component N. Kapag ka sila ay homogeneous of the same degree, then we can proceed with the substitution y equals vx or x equals yv. Right? Pero dapat sila ay homogeneous muna. So if we will let M to be equal to x minus 2y and n of xy be equal to 2x plus y, then we have the following. First, yung m of lambda x, lambda y ay equal lamang kay. So this would be lambda x minus 2 lambda y. And then I can factor the lambdas out. I'll have lambda ng x minus 2y. But x minus 2y is precisely m of xy. So this is lambda m of xy. So we can say that m is homogeneous of order 1. Right? And similarly, I'll do the same. I'll check kung ganun din yung yung degree ng homogeneity ni function n. Gawin ko siya kay n din. So n of lambda x, lambda y. Because again, I'm first checking for the homogeneity. Nagputol na ba ako? Nagreklamo na yung internet ko eh. Kailangan ko ba mag-rejoin? Ayan, naputol na nga ako. Pero I hope I'm back. Can I see some reaction or feedback? Okay pa ba ako? Or putol-putol? Konti lang. Okay, thank you, Victor. Kasi nagrereklamo yung nagrereklamo si Teams. Pero anyway, yeah, we're checking for homogeneity of n. So kay n, lahat ng x, palitan ng lambda x, lahat ng y, palitan ng lambda y. So for n, we'll have what? 2 lambda x plus lambda y. And then I'll factor out the lambda. I'll have 2x plus y, which is precisely nxy. So from these statements, we can say that m and n are both homogeneous of order 1. Ang tagal ng lag. Kasi hindi ko pa siya nakikita dun sa monitor, pero nasulat ko na si m at saka si n ay parehas homogeneous of order 1. Okay? Sige, let's give, sorry about that. Let's give my internet a little time para ihatid sa inyo yung statements. Okay, pero I hope you get the idea. Una yung gagawin, ipakita muna or i-check muna na homogeneous yung mga components ng ODE of the same order. Sorry, of the same degree. Ayan, nalilito ako sa degree at order. So, dapat sila ay homogeneous of the same degree. Okay? Tapos, pag sure ka na, napakita mo na sila ay homogeneous or lahat ng components ng ODE ay homogeneous of the same order, then carry on with the substitution. Okay? Hopefully, makahabol yung aking share screen. At hindi siya humahabol. Ano? Pero naka 4 bars naman daw ang internet ko, so hindi ko alam kung bakit. Yeah. Probably let's take let me try recording. Sorry, recording. Let me try restarting. Ay, kita na yung therefore. So ako lang yung hindi nakakita nung therefore. Ayan, nag-move na siya. Okay. Yan, hindi na natin kailangan mag-break. Nakaabot na rin siya. Oops. Super delayed siya sa akin. Pero anyway, at least sa inyo hindi delayed. Okay, so copyin ko lang to dun sa kabilang page para alam ko yung sinusolve natin. Okay. Ayan, nakikita ko na siya paunti-unti. Alright. So, dahil homogeneous of the same degree yung mga components ng ODE, I can use the following technique. I will let y be equal to vx. Nag-change of variable ako. Pero remember, pag nag-change ka ng variable in something that involves the derivatives or differentials, you should also make the appropriate changes in the differential. So if my plan is to let y be equal to vx, kailangan kunin ano yung pang-substitute kay dy. Ano yung differential ni variable y. Okay? So para ka lang talaga nag-u-sub sa integration. So kaya lang si v ay posibleng function then of the variable x, right? So that means I need to use the product rule here. V is not just a constant. V is something that involves the independent variable. So that means if I want to find the differential of y, and y being the product of v and x, I need to use the product rule to get that differential. Okay? So ibig sabihin si dy, lahat ng dy mamaya, pag pinalitan ko na si y ng vx, dapat lahat ng dy, papalitan ko rin ng vdx plus x dv. Alright? Changing the variables requires changing the differentials as well. Now, if I will implement this, okay, tingnan natin yung mangyayari sa equation. So dun sa given equation, lahat ng x's ay mariretain, lahat ng y's papalitan ng vx, yung mga dx mariretain, yung mga dy papalitan ng vdx plus x dv. And you see, it would be a nightmare of substitutions. Ano? Kasi mas humahaba yung mga expressions. But we don't have any choice but to do the hard work here. So, simulan na natin. So then I'll have x minus 2vx times dx, medyo okay pa itong una, plus 2x, tapos yung y nga, papalitan ng vx. Kaya lang yung dy, mapapalitan ng v dx plus x dv. Okay? Equals 0. Okay? Sana sir may pupuntahan yung pinagagawa mo ha, kasi humaba ngayon. Kasi dito sa second term, magpo-FOIL method ako dyan. Now, the promise is kapag ka homogeneous of the same order, of the same degree, yung mga components ng ODE, dapat ma-reduce natin to in a separable differential equation. So dapat ito, ma-separate natin yung may mga x's at saka yung may mga v's. So I need to expand the right-hand side to really see na separable sila. So expand, so we'll have x dx minus 2v x dx plus, so FOIL method, 2xv dx plus 2x squared dv plus v squared x dx plus, sorry, nasa na ako? V squared dx plus vx squared dv equals 0. Hopefully, tama yung pinagagawa. Alright? So, double check ko nga. 2x times this guy, so that's 2x v dx. Then that guy times this, so that's 2x squared dv. And then vx times this guy, v squared x dx. Then this guy times that guy, it's going to be v squared dv equal to 0. Alright? Tapos ngayon, i-collect natin lahat ng may mga dx at collect lahat ng may mga dv. So una, lahat muna ng may mga dx. So this guy has a dx, pa-factor ko si dx, matitira ay x. Luckily, this one will be canceled by that one. So nabawa yung dalawang terms. Tapos susunod na may dx ay ito. So I'll have plus v squared x times dv. Times ba dv? Times dx. Tama ba? Alright. So this is already accounted for. This is already accounted for. So yung may mga dv na lang yung natira. So yung may mga dv naman, 2x squared plus vx squared, factor out si dv equal kay 0. Alright? Tapos gusto natin silang i-separate. Tingnan natin kung kaya. Well, dito pwede muna ako mag-factor ng x times 1 plus v squared dx plus, or actually pwede ko nang i-transpose ito. Maging equal siya sa negative 2x squared plus vx squared dv. Right? Tapos, pwede ako mag-factor dito ng x squared. So I'll have a negative x squared. Tama ba? Negative x squared ng 2 plus v dv. Double check. Negative, okay. Negative x squared. Everything's good? Sabihan nyo lang pag may na-miss ako, lalo na na-sign. Tapos separable ba to? Well, we can divide both sides by 1 plus v squared para mawala yung may v squared dito sa kaliwa. Pupunta siya sa kanan. Tapos sa kanan, magdi-divide naman ako both sides ng x squared para mawala yung x squared dun sa kanan. So indeed, it is a separable differential equation. In particular, in separated form, this looks like what? X over x squared, so that's going to be x to the negative 1 dx equals negative of 2 plus v over 1 plus v squared dv. All right? Tapos ngayon tayo mag-integrate kasi separated na sila, and this should be not a shocker kasi nga siya ay separable. Siya ay homogeneous of the same degree yung mga components ng ODE. Ito talaga yung gusto nating maging outcome. So, we'll deal with this separated differential equation. Let me do it on the other page. Ang gagawin ko lang ngayon, mag-i-integrate tayo. Right? So the first one, the left side is easy to integrate. This will just be ln of the absolute value of x. I'll defer the arbitrary constant for it. Sasama ko na siya dun sa arbitrary constant dun sa kanan. Kaya lang, paano natin to evaluate? Well, pwede ko siyang hatiin sa dalawa. Pwede ko itong isulat na integral muna ng 2 over 1 plus v squared dv plus integral ng v over 1 plus v squared dv. Tapos madali itong i-integrate, right? So this guy, or the first term, could be evaluated as negative ng what? Negative ng 2 arctangent ng v plus an arbitrary constant, pero i-defer ko na lang yung arbitrary constants, so magkakaroon tayo ng negative integral ng v plus 1 plus v squared na matitira. Right? But for this, I will let u be equal to what? Be equal to 1 plus v squared. So sana natatandaan nyo na yung mga techniques of integration. This will be equal to du equals 2v dv. All right? And that's what I wanted here para mas simple yung integral dito. So yung substitution na usual, yun lang yung in-implement ko. So we'll have the following. Ln of absolute value of x equals negative 2 arctangent of v minus integral ng, so yung v dv na nandito ay mapapalitan ng du over 2. So I'll have du over 2 all over 1 plus v squared is simply u. So then we'll have negative 2 arctangent ng v minus 1/2 gawa ng constant na nandito, that's integral ng du over u. That's ln ng absolute value ng u. And then finally, I'll write the arbitrary constant c. Okay? Any questions so far? Ano yung kalaban talaga natin? Techniques of integration. Ano? So kailangan talaga natin siyang i-review. So far, ang meron na tayo ay, oops. Kaya ako dito ng another column. Okay. Meron na tayong ln ng absolute value ng x. So magre-revert lang ako pabalik sa variable y and x. So this will be negative 2 arctangent ng v, pero ang v ay, remember, si y ay equal kay vx, so that means v ay equal kay y over x. So gamitin ko yon. Si v ay equal kay y over x minus 1/2 ng ln ng absolute value ni u, pero si u ay 1 plus v squared lamang. And that's always non-negative, so pwedeng tanggalin ko na yung absolute value bars. Tapos ano pang meron dito? Well, pwede ko itong ibalik sa variable x, sa variable y and x. Instead na v squared, magiging y squared over x squared siya, plus the arbitrary constant c. So you can't stop here, right? Kasi wala na naman yung mga derivatives. And it doesn't look like I can write it in explicit form. Pero if you want to make pasikat at sabihin mo, sir, magaling ako sa laws of logarithms, so you can continue, ano? So you can do it as ln, or basically para mawala yung problema ko about exponents, I can multiply both sides by 2. So I'll have 2 ln absolute value of x equals negative 4 arctan ng y over x, then minus ln ng 1 plus y squared over x squared plus an arbitrary constant k para i-factor in yung multiplication by 2, right? Kasi nag-multiply ako ng 2 both sides. Bakit ko siya ginawa? Para itong left side, masulat ko na ln na lang ng x squared. Right? ln ng x squared. Tapos ito, pwede kong i-transpose, magiging plus ln ng 1 plus y squared over x squared equals negative 4 arctan ng y over x plus k. Tapos dito, pwede ako mag-loss of exponents. Remember, this will be ln, or the logarithm of a sum is the ln of the product. Okay, so this will become x squared times 1 plus y squared over x squared equals negative 4 arctan ng y over x plus k. Tapos, you simplify this guy, this will become ln ng x squared plus y squared equals negative 4 arctangent ng y over x plus k. And this one is much neater to look at than the other solution, right? Other than compared to this guy. Pero I'm perfectly fine with this as your final answer. Okay? Pero yun nga, kung kaya nyo naman siyang i-simplify, yeah, extra steps won't hurt. This looks much neater than this one. But both are acceptable and both will merit perfect credit for you. All right. Ang haba ng mga nangyari. Any questions? Okay lang ba? Kaya pa ba na next example? Ano man time slot natin? 10 to 11:30, no? So, yeah. May time pa tayo for some more examples. Pero maganda rin to na review ng calculus, ano? May tanong si Victor, bakit negative ln1 plus y squared over x squared ulit? Saan yun nangyari? Ito. Dito ba yan, Victor? Well, remember, sige, let's retrace our steps. Okay, so ito yung integral niya. Alright? So after integrating this, nagkaroon ako ng negative 1/2 ln u. Pero remember, si u ay 1 plus v squared. So this was ln u, right? ln u. Pero si u ay 1 plus v squared. So this was 1 plus v squared. Pero saan equal si v? Si v ay equal sa y over x. So kaya ito ay naging 1 plus y over x quantity squared. Kaya naging ln ng 1 plus y squared over x squared. So yun yung medyo kailangan yung i-keep track. Yung mga changes of variables dito. Right? So u ay equal kay 1 plus v squared. Pero si v ay equal kay 1 over x. So ultimately, ln of u will be equal to this. Okay? Kaya dapat medyo organized yung pagkakasulat nyo ng solution. And as much as possible, mas okay na step by step. Okay? Sige, isa pang example. Okay. Before we proceed, particular solution muna. Because here we have a general solution. Okay? It's a general solution because hold on. Convert. Oops. Copy ko lang to. We have a general solution because here we have a representation of all the possible functions y, okay, in terms of the independent variable x or a condition there too na makakasatisfy ng ODE. Pero meron siyang parameter k kasi kino-consider natin yung infinity of solutions for this particular ODE, for the ODE. Pero if we have an initial condition in mind, for instance, in this example, we want to find the solution curve or the integral curve that passes through 2, negative 2. Gagawin ko lang, kailangan nating hanapin yung constant k that will give us this initial condition. Okay? So paano siya gagawin? Well, we take note that we already have the solution. So from the previous example, from before, we know that the general solution, sorry, hindi kakasya. Sana nababasa nyo pa. So from before, we know that the general solution is this guy. Walang pang period. Andito yung period. So if x equals 2 and y equals negative 2, plug in natin sila to find the value for k. So we'll have ln ng 2 squared plus negative 2 squared ay magiging equal kay negative 4 arctangent ng 2 over baliktad. Oops, sorry. Negative 2 over 2 plus k. So what I just did is to replace all x's by 2 and all y's by negative 2 para mahanap natin sino yung k na specific para dito sa condition na kapag ka daw si x ay 2, dapat si y ay equal kay negative 2. So that means, again, from the general solution, replace all x's and y's by the respective initial values. And then from there, we will solve for the arbitrary, this time di na siya arbitrary, but we'll compute for the corresponding constant capital K, right? So here we'll have what? We'll have ln ng, 4 plus 4, ln ng 8, okay? Equals negative 4 arctan ng negative 1. Anong arctan ng negative 1? Ang arctan ay nandito, negative 1. Ang tangent ay nagiging negative 1 kapag ka ang x mo ay andito. Negative pi over 4, right? Kasi ang sine ng negative pi over 4 ay negative 1. Ang cosine niya ay positive 1. So ang tangent ng negative pi over 4 ay negative 1. So that's the arctangent I'm looking for. So this will be negative 4 times negative pi over 4 plus k. Dahil wala naman yung option natin sa arctan ng negative 1, no? Pi over 4 or negative pi over 4. But it should be negative pi over 4 so that it's on the fourth quadrant. So here we will see that k is equal to what? It's equal to pi or negative pi ba? Kasi ito ay magiging positive pi. So negative pi plus ln 8. This is positive pi. Lilipat sa kabila, ln 8 minus pi. Mas okay yung itsura ng negative pi plus ln 8. Okay? So therefore, the particular solution we're looking for, dito na lang. Oops, yeah, is this guy. Sorry. Ito pala yung space ko para dun sa solution. So therefore, our particular solution is ln ng x squared plus y squared. Ano nga yung itsura? Hold on, kalimutan ko na siya. Ay equal kay negative 4 arctan ng y over x plus the value of k, but we know the value of k is pi minus ln, negative pi plus ln 8. Negative pi plus ln 8. So this is our final answer. Or, yeah. So ito yung particular solution. A negative pi plus ln. Okay? Any questions? So kailangan matyaga pag-i-integrate at matyaga kapag ka mag-expand, magsosolve ng mga equations. Ano? All right? Again, one more example. Nakakatakot yung next example kasi may cosecant. Ano? So, but let's see. Again, the first step is to see if the components m and n of your ODE are both homogeneous and of the same degree. Okay? So, yun muna yung gagawin ko. So, I will let m to be the first one, or m of xy, be equal to x cosecant ng y over x minus y, and n of xy be the second component. Si x lang naman pala siya, so madali yung pangalawa. Okay. Then, let's check if they are homogeneous and hope that they are homogeneous of the same degree. So to check whether m is homogeneous, so kunin ko yung mx, my, and put that inside m. So we'll have lambda x times cosecant ng lambda y over lambda x minus lambda y. Okay. Simplify it, we'll have lambda x cosecant ng, luckily, na-cancel lang yung lambda doon. So y over x minus lambda y. Tapos, pwede kong i-factor out si lambda. Pag finactor out ko si lambda, matitira ito sa first term, matitira ito sa second term. Oh, but that is essentially m. All right? So this is equal to m of xy. So we can say that the component m is homogeneous of degree 1. So we're hoping now that the component n will be homogeneous of degree 1 as well. Pero mas madali siyang tingnan, no? So kasi si n lang naman ay x, the x function. So palitan mo si x ng lambda x, you'll have lambda x, which is a homogeneous one. So that is m and n are homogeneous of degree 1. Dahil yung dalawang components ng ODE ay parehas homogeneous of degree 1, then we can separate the variables. Okay? And that could be done by a simple change in the variable. So let me just copy the given. Oops. Para dito tayo mag-solve. Sala. Okay. So parehas silang homogeneous of degree 1. So I will let y be equal to vx. And again, a change in variable will require a change in the differential. So dy will be v dx plus x dv. And then let's do the work. Ano? So this would be x times cosecant ng vx over x minus vx times dx plus si x ay mariretain, si dy lang yung mapapalitan ng v dx plus x dv equals 0. Alright? So lahat ng y's, pinalitan ko lang ng vx, tapos lahat ng dy, pinalitan ko ng v dx plus x dv. And I hope you get the pattern kung sino yung pinipili mo na napapalitan. Okay? Kasi rito, kapag ka nag-let ka ng y equals vx, expect that dy will consist of two terms. Okay. Ang kasama ni dy ay monomial lamang, so mas madaling mag-multiply ng x times eventually a binomial. Kaya ang pinili ko si y ay equal kay vx. Imagine the difficulty if I will use the substitution x equals y v instead. So ibig sabihin si dx naman yung magiging komplikado. So yung dx dito magiging si dx dito ay magiging v dy plus y dv. Alright? Siya yung magiging binomial, ita-times mo ng binomial, so magpa-FOIL method ka. Alright? So you can avoid some of the algebraic nuances kapag ka maganda yung napili mo na substitution. Either will be fine, pero siguro sa integration, medyo mas mahirap yung isa than the other. Okay? So at this point, we can We can expand and collect all those with dv's and those without. So, pwede ko muna pala itong i-simplify. So, I will have x cosecant lang ng v minus vx. Lahat na sila ay may dx. Plus, expand ko yung kabilang group. So, it's gonna be x v dx plus x squared dv equal kay 0. Alright? Tapos, meron tong dx. So, isama ko ito doon sa grupo na yon. So, it would be x cosecant v minus vx. Tapos plus xv. Meron akong vx. Merong xv. So, magka-cancel lang sila. So, mauubos. Isa na lang yung term na matitira na may dx plus x squared dv equals 0. Tama ba? Or excited lang ako na ma-simplify siya masyado. Pero I hope this is okay. And then I can transpose the dv term to the other side, negative x squared dv. And then now I do the separation. I divide both sides by what? By cosecant v x squared. Doing so will give us x divided by x squared. That will just be x to the negative 1 dx. Then this would be negative, supposedly dv over cosecant v. Pero ang 1 over cosecant v ay equal lamang kay sine v. Tama? Sine v dv. All right. Then we integrate. So the next step is, lagyan ko na ng period doon, next paragraph. So ang integral ni ln x, excited, integral ni dx over x ay equals sa negative integral ni sine v dv, right? Tapos ito ay ln ng absolute value ng x. I'll defer the arbitrary constant later. Tapos integral ng sine v. Anong integral ng sine v? Ang integral niya ay negative cosine. Tama ba? Kasi ang derivative ng negative cosine ay negative ng negative sine sa positive sine. Right? So this integral is negative cosine v, pero may negative sa labas. So that would be positive cosine v plus the arbitrary constant c. All right? And then we revert to the original variable. Balik lang tayo sa variable x and y. So yung v dapat mawala siya. Pero we know that v is simply y over x. Tama ba? Y equals vx. So v equals y over x. Y over x. So this is cosine ng y over x plus the arbitrary constant c. And you can stop here. That's our solution. All right. Any questions? Okay pa ba? So you can take a screenshot. Okay. Luckily ngayon, wala nang maraming LNs, ano, so hindi natin napagsasama yung LN at saka yung cosine. So we cannot do anything about it. So we can stop there and let's see if I have more examples here. Sige, we can solve this one. Hopefully mabilis lang siya. We have 7 minutes left. Pero I marked this kasi ito yung isang specific time na mas madaling gamitin yung x equals yv. Okay? Kasi rito, si dy, pag nag-let ako ng y equals vx, so si dy ay mapapalitan ng v dx plus x dv. So dy, here this will become a binomial times another binomial. So it will be a something with 4 terms at the most. Ano? So medyo mahirapan tayo mag-compute. Compared kapag ito na lang yung pinalitan ko. Right? So ang gagawin ko dito ng substitution ay substitution ay x equals yv. Okay? So ilagay ko rito ay exercise. So please show that both components, I think you can do it. So para lang mixing yung isosolve ko para kumasya dun sa natitirang 6 minutes. Ano? So please show that both components are homogeneous of degree 1. Ako lang yung pwedeng gumawa ng pakiusap na ganyan. Wala ako dapat makikita sa homework na may nakalagay na, "Sir, please show that both components are homogeneous of degree 1. Trabaho nyo yon. Ano? Saka kasama siya dapat ng solution. Kasi kailangan nyo i-justify na talagang siya ay pwedeng gamitan ng method na natutunan natin under section 2.2. Alright. So, after you have done that, pwede na natin gawin yung substitution. But again, I suggest we use the substitution x equals yv. So here I will let x equals yv and consequently dx will be y dv plus v dy. Then the equation will become this. We'll have yv times y dv plus v dy plus y minus 2yv times dy equals 0. Okay? So, ibig sabihin, we will have what? Okay, for the first term, we're going to have y squared v dv plus yv squared dy plus plus y minus 2yv dy equals 0. In-expand ko lang yung first term. Tapos, i-combine ko lahat ng may mga dv at mga may dy. So, nag-iisa lang yung may dv. Yung may dv lang ay y squared v dv. Tapos, yung grupo na meron dy ay yv squared minus 2yv plus y dy. Okay? Naka-dy na to, so isasama ko na lang itong may dy doon sa loob ng factor. Okay? And then hopefully this is separable. Okay? Sige, unahin ko ng paghiwalayin yung dalawang equation. Paghiwalayin yung dalawang terms. Let me copy this to the next page. Take your screenshots now if you want. Okay, move to the next page. So, ang gagawin ko ngayon ay ita-transpose ko to. So, ito ay magiging equals, tapos ito ay magiging minus sign. Yan yung meron tayo. Okay? And then we try to separate. So, I'll have y squared v dv equals, dito pwede ako mag-factor ng, pwede ba mag-factor? Pwede ako mag-factor ng y mula dun sa kanan. So, siya ay magiging negative v squared minus minus 2v plus 1 times y dy. Okay? And then separate. So, we'll have v over v squared minus 2v plus 1 dv equals negative y over y squared. So that's y to the negative 1 dy. Okay, I think this is good. Yes, Renato, saan dapat yun? Meron bang mali? Just let me know kung merong problema. Sa pag-factor. Dun sa ifa-factor kanina, right? So, naghang ako kanina kung ano yung pwedeng i-factor dito, no? Tama nga ba? So, mag-factor ka ng y, kaya ako nalabas yung y na yun. Okay, thank you. So now we're ready to integrate. So, ito ay what? I-flip ko lang ng konti kasi madaling i-integrate ito, ano? So, that will be negative ln ng absolute value ng y. Ito yung integral niyan. Plus an arbitrary constant that I reserve for later. Tapos ito, magpa-partial fraction decomposition ako. Right? Kasi meron akong linear over quadratic na repeating. So if I do partial fraction decomposition, this will become integral of a over v minus 1 plus b over v minus 1 quantity squared dv. Kala nyo nakatakas na kayo sa partial fraction decomposition. This denominator can be written as v minus 1 quantity squared, repeating factor, pero linear yung repeating factor, so the numerators would be constant, or some constant a and b. Okay? Now, siguro we can solve on the side for a and b, so on the side. So here, we should have, so gusto natin yung eto, ay gusto kong maging equal sa v over v minus 1 squared. Right? That's the end goal. Kasi i-decompose ko itong mahabang fraction na to with the sum, as the sum of two fractions. Yun yung idea ng partial fraction decomposition. Now, to get the values of the constants a and b, I can multiply both sides by v minus 1 para mawala yung mga denominators. Multiply both sides by v minus 1 squared. So I'll have v minus 1 times a plus b equals v. Right? And this should be true for all v in R. Totoo siya sa lahat ng value ni v. Now, kung totoo siya sa lahat ng value ni v, universal instantiation, dapat totoo siya sa v equals 1. Kapag kasi v ay equal kay 1, this guy will be 0 times a, that's gonna be 0. So we'll have b equals 1. Kasi nga si v ay equal kay 1, ito ay magsi-0, matitira si b equal kay 1. So si b ay equal kay 1. So kailangan nating mahanap ano yung value ni a. So para mahanap yung value ni a, bigay pa tayong isang value ni v. You can use any value of v you want kasi totoo naman to for all v. Pero I'll use 0 para madaling mag-substitute. Kapag si pag si v ay 0, here I'll get negative a plus b, but I know the value of b is 1, so equals 1, plus 1 equals 0. Kasi nga si v ay 0. Tapos here we get a equals 1. Okay? Parang hindi to yung nakuha ko kagabi. Tama ba? Sana tama. So ito yung a and b. Negative 1 ba yung nakuha ko? B minus 1. Parehas ba siyang positive? Yung isa yata dapat negative. Tama ba? Tama naman yung ginawa ko, no? Nagduda ako bigla. Pagka si v ay 1, ito ay magsi-0. B equals 1. So that's good. Kapag si v ay 0, this would be negative a plus 1. Negative a plus 1 equal kay 0. A equals 1. Do you agree? Tama ba? Or hindi nyo na alam yung ginagawa ko? Sana tama. Okay, thank you guys. So that means dito, copying ko lang to. Pagpatuloy natin yung solution. Okay. So that means this guy will be the integral of 1 over v minus 1 plus 1 over v minus 1 quantity squared dv. All right. Sige na, double check ko na v minus 1 squared plus v minus 1. So v squared minus 2v plus 1 plus v minus 1. Cancel, cancel. Sorry, v minus 1 lang pala. V minus 1 plus 1. Okay. So tama naman siya. All right. Okay, so integrate both terms. This will be ln ng absolute value ng v minus 1 plus dito kailangan ko sorry, madaling ko na kasi time na. So dito magle-let ako ng u to be equal to v minus 1. So that means du equals dv. So yung pangalawang integral ay integral lamang ng 1 over u squared. So that would be u to the negative 2. So this would be v minus 1 to the negative 1 over negative 1 plus c. Yeah, this is right. So this is ln. Babalik na ako ngayon sa variable x and y. So this will be ln ng ang v natin ngayon ay, anong sinubstitute natin? X equals yv. So si v ay x over y. X over y minus 1 plus, so magiging negative na siya. Negative ng 1 over, okay, x over y minus 1 plus the arbitrary constancy. And due to lack of time, I'll stop here, but you can put this together, right, using laws of logarithm. Nawala si Victor dun sa pagko-compute ng values ni A and B. Pa-review na lang ng partial fraction decomposition kung paano siya ginagawa. But essentially, I am looking for the constants A and B so that this equation will be true, right? So kailangan ko lang si A and B. So ang ginawa ko, I want to get rid of the denominators first because who really enjoys working with fractions? Definitely no one, all right? So we multiply both sides by v minus 1 squared para mawala to, mawawala to. Tapos ito mawawala pero may matitirang v minus 1 sa taas. And hence, you get this. And this should be true for all values of v. So ngayon, magbibigay ako ng convenient values of v para mahanap si A at saka si B. Kapag ka si v ay 1, magzi-zero yung first term, mawawala si A, so magiging B equals V, which is equal to 1. Tapos bigay pa ako ng isang convenient value for V, say V equals 0, so this would be negative A na siya. Ang B alam na natin ay positive 1, equals siya kay V, which we assume to be equal to 0, so there we get this one. Okay? So kung medyo nalimutan na, balikan, partial fraction decomposition. Okay? So take your screenshot here, double check this solution. Medyo ngayon lang uli ako nagsasolve ng mga mahabang integration at differentiation. So let me know if some needs to be changed, kung meron dapat i-correct. Pero I hope the solutions are correct, or at least the idea, the process came across. Okay? So next meeting, is there some more examples? Okay. So siguro, magpapa-homework ba ako ulit? Sige, dagdag nyo na sa homework, pero ang deadline nito ay gagawin nating Friday next week. So, I'll post it na lang dun sa Canvas. So, tingnan nyo na lang siya as isang homework na 2 items. Alright? Pero mas later yung deadline nito. Probably you can choose one among the 5 exercises. For homework number, anong number na to? Homework 3 na ba to? Okay, thank you, Dino. Yeah, homework number 3 na to. I hope you don't mind the too many homeworks. Mas okay kasi method scores kasi talaga tong 151. So, kailangan practice ng practice. So, para mapilitan kayo mag-practice, I'll give specific homeworks for every class. So, homework number 3, pipili uli kayo ng isa dito sa 5. Okay, sige, pwede. Isa dito sa 5, isa lang dun sa 5, pero it doesn't hurt, and actually it's better if you will try to answer all 5 of them, pero isa lang yung isubmit nyo. And then, by the way, what I did with homework number 1, nag-provide ako ng answer key. So, kapag ka na-submit nyo na yung homework, you can go to the answer key page dun sa Canvas page natin, and then you can download the answer key or the sort of the my solutions to the problems. Pero disclaimer, hindi lahat doon ay laging tama. So you can please take it with a grain of salt. So paki-review kapag may typo o meron akong little mistake na nagawa or kahit malaking mistake, let me know para makorek ko, right? Pero ang idea doon ay para makita niyo yung ma-check niyo yung solution niyo doon sa iba na hindi niyo sinubmit. Kasi I will give you immediate feedback or timely feedback for the ones that you have submitted. Pero kung itatry niyo yung 5, syempre gusto niyo malaman kung tama yung solution niyo, I can make an answer key for that. Okay? But my only request is that you download the answer key only after you have submitted, of course, your that requirement. So access only the answer key to homework 3 if you have submitted homework 3 already. And do not share it with your classmates kasi lalagyan ko ng parang oath yung page na by accessing the page, you attest upon your honor that you have submitted the corresponding homework, saka nyo siya i-download. So kanya-kanya na lang download. Don't share it with your classmates. Let them download it for themselves. Okay? So, sorry, super overtime na. Alam ko yung iba tatakbo pa sa kanilang face-to-face class. Sorry about that. But again, if you have classes like this, you can go ahead. 11:10, pwede na kayong umalis. Ay, hindi pala, 11:20, sorry. 11:20, you can leave the meeting, and if I took some extra minutes, you can watch the recording later. All right? Any other questions or concerns? Okay, kung wala na, so thank you guys for joining me today. Hopefully, na-refresh kayo sa integration techniques, And keep doing reviewing those topics from elementary calculus kasi kailangan natin sila lalo na sa mga susunod na parte ng kurso. So next week we will deal with section 2.3 which is exact differential equations. So medyo ma-adjust ng konti yung ating calendar. So but anyway, that's fine. Ang gusto natin maintindihan natin siya at hindi lang basta ma-cover yung coverage ng bawat linggo. All right? And on that note, enjoy the weekend, guys. Let's see each other again on Wednesday. Bye.
Thank you, sir.
Thank you, sir.
All right.